Hey, good morning, NDC Minnesota. Hopefully you're here for the right talk, Docker on Windows. It's going to be a very kind of fast-paced session. There's a lot of demos for us to get through, so there's not too many slides. But we'll just kind of start off with an introduction to myself. So I'm currently a software developer, also very passionate about site reliability engineering, so I'm an advocate for that within our company. And I'm also a co-organizer of the Shropshire Devs user group for developers based in Shropshire, UK. So if you've not noticed already, my accent isn't from around here. So apologies if you can't understand me as well. So the aim of this session, we're going to go through and understand what Docker is and why you'd potentially want to use it. We're then going to look at, okay, moving forward from that, if you want to get started, how do you do that on Windows? Next, we're going to take a .NET Core MVC application that's running inside Visual Studio, and then we're going to convert that to both build and deploy using Docker. And then lastly, we're going to look at how can we use a feature of CloudFlare called Argo Tunnel to then expose our container securely to the internet, making use of all of CloudFlare's services as well. So what are containers? So containers wrap up a piece of software in a complete file system. That contains everything that it needs to run, including the code, the runtime, the system tools, and also the system libraries. It's basically just a way of saying we package up your application and its dependencies. Containers as well are also what we call a running instance of an image. So we actually build an image, and then we create a container from that image. So what is Docker exactly? So Docker was kind of started in around 2013 with its initial release, with its first full production release for Linux in 2014. Docker is a tool that builds on the concept of containers and images, and is one of the various implementations of that. And that then allows us to create those containers. And as of a few years ago, we can now do that on Windows as well. So you can run it on Linux, Windows, and Mac OS, although today we're focusing just on the Windows side of things. Cool features are coming out all the time for the Windows platform, but just because of its age compared to Linux, it's not as mature. So occasionally you will see features out there that just unfortunately don't work on Windows at the moment, but they are actively working on a lot of those. So how can containers help you in your work? I think we've all been there. We've all kind of wrote some code, we've deployed it, it kind of worked in dev or it worked on my machine, and then we get to production and it burns down. Usually because of configuration drift or because of missing runtimes on those servers. And traditionally, ops used to be the people to try and clear that up for us. So Docker tries to help us with that. And that's because it can then help us reduce those deployment issues, because we're using the same container to run on our local machine than we are on the dev machine, on the QA machine, and in also production. And it also helps kind of reduce kind of single point of failure as well from a human perspective. People that have worked in some organizations might know there's kind of one or two people that kind of just know everything. And when production's on fire, those are the people that go and rescue it, and we kind of have to then guess and trust them to know what's going on, where Docker and containers forces you to put some of that configuration into the container, so it's documented that way. And then when you want to release for various environments, the only difference is you inject different configuration through environment variables or configuration files. So if you're going to use Docker or any other containerization technology, there is going to be some mindset changes that you're going to have to kind of go through. So the first one is a lot of us are used to kind of having what we call snowflake servers. So somebody hand-built them, the documentation's very poor, it's really hard to recreate that server when it dies or if you want to scale that server up. So you need to start treating kind of your Docker containers as cattle rather than as snowflakes. And one way we do that, like I mentioned in the previous slide, is configuration through code. So we put all of our configuration into the Dockerfile so that we know exactly what goes into that image, what configuration's needed. And building on the kind of mindset changes, if a container starts misbehaving, unlike the old days where you go and troubleshoot that server, you don't with containers. You typically just kill that container and spin up a new instance of the container, and typically that will resolve most of your issues. And that also plays in well for stuff like Chaos Monkey from Netflix, which then randomly kills some of their containers and services, and then you can see how your infrastructure responds to that. So that's a good tool that once you get a bit more in depth with Docker, that you can start looking at chaos engineering as well. So what are the differences between virtual machines and containers? So on the left-hand side of the image, we've got a traditional kind of virtual machine setup. So we've got our infrastructure, we've got our host operating system, which is obviously probably going to be Windows Server or potentially VMware or something to that nature. And that also includes the hypervisor. We then got our big, thick guest OSs on top, libraries that we need for the application, and then our application itself. But it's very wasteful in this approach because you've got a separate big fat OS installed for every application. Whereas on the right-hand side, with the container approach, you can see that we actually share the operating system from the host, and that the only difference is then we've just got our application and the libraries that our application depends on, and we run that on top of the Docker engine. And the advantages of using containers in this scenario is that containers are extremely lightweight compared to virtual machines, which means that they're a lot smaller footprint, faster startup times, and also more reliable, as we've covered in previous slides. So using containers, you can have a lot more instances of your application running on the same amount of infrastructure, and then you can independently scale whichever service that you need, rather than scaling a whole server that's running 10 applications, for example. In the Windows world, however, we've actually got two types of containers. We've got something we call Windows Server containers, and we've also got Hyper-V containers. As you can probably see, the Hyper-V container is a little bit more like a virtual machine. It does have a separate Windows kernel, so it doesn't share the kernel from the host. But that Windows kernel and the OS is a lot smaller than what you traditionally see on a VM by a few degrees. The reason that we've got two different types as well, you can use both on Windows Server 2016, but on Windows 10 you're limited to the Hyper-V containers only. And that's because Windows 10 doesn't have some of the support that's needed for Windows Server containers. If you're working in a very kind of secure environment as well, you'll probably want to be looking towards the Hyper-V containers just because there's a higher degree of separation there because you have got your own kernel. So if you want to get started with Docker, how do you do that? So Docker, I've got a product called Docker for Windows. Just bear with me 2 seconds. So this link in the slides takes you to the Docker documentation, which walks you through the installation, but it's basically just download the exe, install it, and then you can go away straight ahead and launch it. It's probably a little bit hard to see on the screen, but you've got Docker in the bottom right-hand corner here, and then you can right-click it, and you've got various settings. So currently I'm in Windows mode, so it's offering me to switch to Linux containers. At the moment, you can, if you're on the stable branch of Docker for Windows, you can only run Windows or Linux containers. There is an experimental feature that's currently in the release at the moment if you've turned on experimental mode, where you can actually run Windows and Linux containers side by side and then network them together. So once you've actually installed Docker, it also, during the installation, install Hyper-V if you haven't got that enabled as well. And you also need to enable virtualization in the BIOS as well. So if you haven't done that, it'll prompt you to do that before Docker for Windows will actually work. If you're on Windows 7 or 8 or 10 Home, there is a product called Docker Toolbox. but that's their kind of legacy product, which they're not really pushing as much anymore, but that does allow you to run kind of Linux-based containers using a different hypervisor other than Hyper-V, such as VirtualBox. And then once you've installed it, you'll get this little pop-up, and Docker will say, Docker's now up and running, and then you can then go ahead and open up PowerShell and start playing with Docker. So for our first demo, we're going to go through the Docker Hub, some of the basic Docker commands, and then get our first container up and running using a pre-built image. In the demo, we're actually going to be using what we call the Docker Hub. So the Docker Hub is a public registry. And the public registry is just a way of people being able to share images. But Docker has recently come out with something called the Docker Store, which they're slowly trying to migrate people onto. But for today, we are just going to focus on the Docker Hub. So I'm just going to head over to the Docker Hub. And I'm just going to search for a pre-built image that I've gone ahead and built ahead of time for us today. This is the particular image here. It's something that I've just created quickly, so you can see that I haven't added a description or anything of that nature yet. But if we pop over to the tags section, so tags in Docker are basically versions. So I've got this image here called Hello Docker 101. But you can have multiple versions of that image. So you could have version 1, 2, 3, 4. And typically in Docker, latest always points to whatever the latest build is. So when you build, you tag it with both the version number from your build system and also latest as well, and then push that up to your registry, whether it be Docker Hub or an internal registry or private registry in the cloud. So I'm just going to head over to PowerShell now. Is that a bit big enough for everybody? OK. I'm then going to ask Docker to go and pull that image from the Docker store for us. If I don't specify the latest tag, Docker by default will add that for us and pull that. But I'm going to be explicit in these commands just because it's a little bit easier to talk through. So I don't have this image locally, but you can see that some of the what we call the layers already do exist. So Docker images are built on layers. So every kind of like command or action in the Dockerfile, which we'll see in the next demo, is kind of a separate layer. And that's really handy. So if you're using the same like we call base image between multiple layers, you only have to pull that data once. And Docker knows that it's already got that layer cached for you on your machine. So it's already gone ahead and pulled all the layers that it hasn't got, and it's told us that it's then downloaded a newer image for us. So we can go ahead now and run that image. Now, if I was to run this command as it is, it would run up the container for us, but it would keep hold of my console, and any output from that machine would come straight to my console. Because I don't want that, I'm going to give it the -D option for detached mode, so it'll start up the process for us and then give me my console back so that we can continue to work. So Docker's going to go and spin up that process for us. And when that's finished, it should give me the console back in a moment. OK, so that's now running. So with Docker, if you want to see what containers are running, the command is docker ps. So if we run that, we can see that the container, and it has wrapped the text, unfortunately, but the container ID is the same kind of short or random ID that you've got up the top there, but we're only seeing the first X characters for that. We then can see the image name that we've used, the command that's currently running within that container, which is what we call the entry point. We've then got the status for it, so it was created 26 seconds ago. It's been up for 12 seconds, and we can see here that it's exposing port 8081. And then lastly, if you don't give your containers a name when you run them, Docker's got just a dictionary, and it randomly picks two words and mashes them together. So if ever you've seen any other Docker talks, or as you go away and play with yourself, you'll see the occasional funny names. If you want to be able to see the logs in the container, which obviously is quite important, we've got the docker logs command. So we can either use part of the container ID or we can use the name. For this, I'm just going to use the first few digits, or characters, sorry, of the container ID. And you can see that Docker's gone away and grabbed all those logs for us and then brought them to the console. So we can see that we're hosting in production mode. We're listening on port 8081, and it tells us that the application started. So that's great, but we currently don't have a way to know what IP address that container is using. So this is where the docker inspect command comes in. So docker inspect command will allow us to kind of inspect all the properties of that container. So I'm just going to give it the container reference again. And it outputs a lot of data. So we can see the created date, the ID, the arguments. But the bit that we're interested in is towards the end of the file. Output. We've got this networks section here. And we can see here that we've got the IP address of our container now. So if I copy that and head back over to the browser, so you can see that this web page now, which is the NDC homepage, which I've just scraped and put into a .NET container running MVC, is loaded. And then you can see that we've got also in the CS/HTML view, we've got the load time as well. So that's the very basics, obviously, of how do I pull a container, how do I run that container, how do I inspect it, how do I look at the logs. Obviously, that's not very useful for us day to day. We're going to want to build our own applications into the containers. So let's go ahead and we'll do that. We will stop the container just to free up the resources. So I'm just going to quickly get the container ID again. So Docker's then reiterated back to me what container it stopped. But this time, if we run docker ps, the container isn't there anymore, except if we add -a to that, we'll see that actually the container is still there, except it's now exited state. So that's still there on disk. Obviously, wanting to be a good citizen of this Docker host, I'm going to clean that clean that container up now. So I'm going to issue the docker rm command and just remove that container. And now if we run docker ps -a again, it's completely gone. So demo 2, I'll just roll straight into that. We're going to take our application, which I'll show you running inside Visual Studio now, and we're going to build that into a Docker container, as well as also using a compose file to then spin that up as well. Just going to delete some files from testing. Okay. So this is our application inside Visual Studio, basic MVC application. So we've got our controllers, we've got our views. So I'm just going to spin this up so we can see what it's like. This is actually the Microsoft's Music Store database sample application. So some of you may have seen this before, but it was just an easy and quick demo. So here's our music store application. We can see that we've got some albums across the bottom here. So we can just click onto any of those, add it to our cart as we'd expect, and also remove it from our cart. So nothing special, but just a basic website. It's using SQL Server on my machine at the moment. So as part of the demo, we'll look at using a database container as well. If you are a Visual Studio user, there is actually a plugin that you can get. So then you can come down to if you're on the project, you can say add Docker support, and that'll go away and then create you some of the Docker files that we saw. But I'm going to do that manually this time. So I'm going to come back to our directory. I'm going to create a file called Dockerfile with no file extension. And I'm just going to open that up. So the first thing that you'll see in most Docker files is the from statement, or the from command, sorry, and that tells us what base image are we going to use for this. So because we've got a ASP.NET Core application, I'm going to use an image from Microsoft. And this kind of syntax highlighting of all the images here, that's a plugin that you can get for Visual Studio Code as well. So I'm going to take the ASP.NET Core build image. So the build image is a lot bigger than the standard image, but that's got all of the build tools in the image that we need in order to compile our code. And then I'm also going to take the Nano Server version of the image. So you've got Nano Server or Windows Server Core images if you're running on Windows. Typically, you want to try and use Nano Server where possible, because that image is a lot more lightweight and a lot more cut down compared to the Windows Server Core image. And typically, if you're running .NET Core, you can use the Nano Server image. But if you're trying to use the full framework, then you'll have to go to Windows Server Core. So now that we've got our from statement, we need to tell Docker to copy some of our source code into this container. So we can do that using the copy command. So I'm going to say copy from the root directory, which is where the Dockerfile exists, and copy it in just to the current location within the Dockerfile. You can use a work dir command to set a particular folder within the container if you want. So if you want it to always be in a certain folder, you can do that, but I'm happy with it just being at the root for this demo. We're then going to go ahead and tell Docker to run the .NET publish command so that we're going to build our website. Telling it I want the release version of my website instead of debug. And then I'm going to ask it to say target the .NET Core Framework 2.0 because the sample application does target multiple runtimes and frameworks. And then I'm going to put the output from that publish command in to just slash output from the root. I'm then going to set my working directory to that output folder of our output that we've just built. And then we're going to use the entry point to say run.net, and then we'll give it our DLL. So that's everything that we need in our Docker file. So we're using the base image, we're copying our files into the image, we're doing a .NET publish, which I'll do the build for us. We're then changing into the output directory, and then we're using our entry point command to then tell .NET to start up with our website DLL. So if I save that file and head back over to PowerShell, I can now tell Docker to go ahead and build that image for us. So I'm going to tag it with my name and then music store latest. And then I'm going to put a full stop or a period after the name of the tag. So that's just giving Docker the context of where to start to copy those files from the previous command. So we're just saying use the root of the demo2 folder. So Docker's now going to go through step by step Each of these kind of steps creates a separate layer, so you can see that we've got a separate ID for each layer. The .NET publish is probably going to take around 1.5 minutes or 2 minutes, just based on the Wi-Fi speed and some kind of unique performance issues that Docker has on Windows compared to Linux. So we'll let that run for a moment. Just while that's running, I'll quickly show you something. So if you're interested in any of the source code for these demos, it's all online on GitHub, and there's a link on the last slide for it. But you've got everything that you'd want to go through any of these demos, including README files, which will take you through exactly the same steps, step by step, giving you the commands and explaining to you them what they do. So that'll be available as well for you. Looks like the Wi-Fi is really fast today. While that's running as well, I'll quickly just jump back to our Dockerfile. So at the moment, we're obviously using the ASP.NET Core build image. Obviously, if you were to be doing this in production, you don't want to be kind of running your compiled source code using that base image. So Docker's actually got something called Multistage Builds. So if I was to go into this file and put in a second from statement, for example, and use just their normal ASP.NET Core image, that's basically just the runtime without all of the extra tools. And then what I could do is I could give this top build step an alias, such as build. And then this one is runtime. And then, And then further down here, I can then go and copy the output. So I can reference the top container using the build tag and say, go into basically the build container and copy my compiled output and now put it into this other container. And what that'll do is it'll give you a much, much smaller image size, which is what you ideally want to be running in production. So I'm just going to back out of those changes a sec. It looks like it's still going. There we go, finally. So you can see in the steps, it's gone ahead and used our base image, it's copied our files, it's run our publish command, it's then changed directories into our output directory, and then it's set the final step to our entry point, which is our music store website. And then it successfully tells us that it's tagged the image as well with the tag that I gave it. Now, as I mentioned before, this website actually depends on a database. And at the moment, I haven't set up my Docker instance to be able to access the resources on my host machine. So I'm going to have to give it a database container for the web application to successfully start up. So I'm going to go ahead and create a Docker compose file. And I am going to cheat and just add one that I prepared earlier. So a Docker compose file allows you to spin up your services, or images, sorry. I'm declaring all my services here. So I've got one service called Music Store Web, which is just a name that I'm giving to that particular service. I then give it the image, which is the one that we've just built locally. I'm then going to tell it to expose port 80 from the container to port 80 on the host. I'm then going to give it an environment string for the database. And you can see here for the data source, we're calling music-store-db. And that's actually the name of the service here, which is a database image that I've gone ahead and pre-created ahead of time for us, just because of time limitations. And then I'm also going to expose that port there. But one of the key things is this depends on attribute. So I'm basically saying the web container depends on the database container. So what Docker will do is go ahead and start that database container up for me first, wait for the process to return back that it started, and then go ahead and start the web container up for me as well. And as you can see here, I don't really have a very secure password either, but it's obviously just for the demo. If you're going to be running this in production, you'd want something like secret management or configuration management type stuff to look into that. So with the Dockerfile now, sorry, the compose file, we can do docker compose up. So that's going to say to Docker, go ahead and spin me up all those services that are in my Dockerfile. So it's going ahead and creating the database container first because it knows that that's depended on by the web service. And that'll take a few seconds. SQL Server containers on Windows are currently around about 15 gigs, so it'll take a few seconds for that to spin up. The same as I did on the Docker run command as well. I've given it the -d flag as well, so for detached mode. So when that's finished, I should get my console back. So it's finished creating the DB container now for me, and it's gone ahead and started the web container as well. So just before we jump into that, I'm going to run docker ps to see my running containers again. I can see that I've got both of them started now. My web container is exposing port 80 as I defined in the Dockerfile, sorry, in the compose file. And also my SQL Server container is also exposing port 1433 as well. I'm just quickly going to go ahead and have a look at the logs of the web container to make sure it started up successfully. We can see that there's a load of just output from Entity Framework and bits and pieces like that, but the important thing is we can see that our web application has started for us. So I'm just going to clear that. And again, we're going to use the inspect command to go and get the IP address of our web container. So there we have it right there. And there we have our music store application running inside a Docker container. And just like before, it's reading from the database. We're able to update the database as well. So I'll quickly just pop back to PowerShell a second. And this time we'll get the IP address of the database container, and we'll just connect to that container and just make sure that everything's there as we'd expect, which we already know, but we'll just show that. So I'm just going to use SQL Operations Studio. So by default, the only username that exists was SA, which we then set the password in the compose file for SA to the really secure one of NDC 2018. we can see that we've got our music store database, and then we can see that we've got data in our albums table. And this is the data that was obviously just being displayed on our homepage. So all this is running inside a container. Database containers are really useful for kind of dev or automated acceptance tests environment. You probably don't want to be using them in production, but for like running AATs, they're really useful because you can spin up a new instance of your database container with your like web container or your console app, whatever your application is that's running in Docker, run your automated tests, and then just tear down the whole environment every time so that you've got a fresh environment every time that you want to run your tests. So the last part of the demo is we've gone through the Docker basics. We've got our web container up at the moment using our database that's got our application in there. But I'm quickly going to show you how to use CloudFlare to kind of expose that web container to the internet securely. So for those of you that don't know, CloudFlare was founded in around 2009. They currently operate in approximately 150 data centers to date. And they offer features such as CDN, DDoS, DNS, web security, web optimization, and a lot more other features as well. For this demo, we're going to use a feature of theirs called Argo Tunnel. And Argo Tunnel, as you'll see from the demo, will allow us to expose our local environment that's running on my machine to the internet through their data centers, and then we'll be able to access it and take advantage of all of their security features as well. Argo Tunnel is in concept very similar to ngrok, if anyone's ever used that before on any of your machines. It's very similar, but obviously CloudFlare gives you the extra security benefits as well. So if you want to get started with Argo Tunnel, obviously you need to go and sign up for CloudFlare, but they've got this developers documentation website, and this takes you through kind of Argo, how you can get that running. And then they've got this really helpful Your First Tunnel guide, so it tells you to go and enable the feature, download their kind of service called CloudFlare D, and that's available for Linux and Windows and Mac OS. And you can also run it in a Docker container as well, if you wanted to. It then walks you through kind of the login process using their CLI. I've already gone ahead and done that process on my machine, so we're actually ready to go and establish our own tunnel. So if I head back over to PowerShell, so I've already gone ahead and downloaded that for Windows. I've also gone ahead and got my certificate as well in this directory for my domain. And it's really easy. So we're just going to say CloudFlare D. Oh, actually, sorry. First, we'll need to get the IP address of our web container again, because I don't remember that off the top of my head. So I'm going to give it the URL to that container on my machine. I'm also going to say host name, so I'm going to go for ndc.ashleypoole.co.uk. I'm just going to run that from the command line this time. So we can see that the CloudFlare D service has started up. It's established connections to my nearest data center of theirs where they operate. And now if I head back over to my browser and go to the URL, we can see that we've got our web application as well. So I've gone all the way back out to the internet through Cloudflare's data centers and then back to my machine securely. So that's useful, obviously, if you've got like a client and you're kind of a design agency and you quickly want to show the client what you're working on. You could use a service like this to show that. Obviously, going more towards production, You could use the Argo Tunnel feature so that you don't have to open up any ports in your firewall. You don't need any network engineers. You could run this process as a Windows service or in a container and just expose your web application to the internet that way. And obviously, you benefit from all of their security features as well. And just to prove that that wasn't faked, you can see here in the output, you can see the requests that were being made by my browser. So you can make sure that I wasn't pulling the wool over your eyes. So if you are going to use Docker, there's a few considerations to go through. One of those is logging. So by default, as you've seen, Docker keeps track of those logs in what we call the JSON login driver. So it just writes those logs to disk in JSON format. Obviously, if you're going to use this in production, for example, you'd want to look at some of the other login drivers for Docker, or have your application log directly to like a syslog server. But Docker has got something called the Docker logging driver. And that gives you the ability to easily integrate with other vendors, such as Splunk, for example. So they ship with a native driver. You can configure that with your Splunk account details, and Docker will automatically then just ship those logs for you straight to Splunk. So all you do is just write to the console, and everything gets sent for you at a host level, meaning that you haven't got to configure those per application. The other consideration is monitoring. I know from an environment that I previously came from, we kind of had a handful of servers. We kind of got good at monitoring those handful of servers, but that process won't scale to containers. So you're going to have to think about how are we going to monitor potentially hundreds of containers that are running. So you'll probably want to look at tools such as like New Relic or Dynatrace and stuff like that, if not already. Docker containers do have health checks that you can register as well, so Docker will periodically check the health of those containers for you. And if they're not healthy, it'll kill the container and restart it back up again for you. Deployment strategy is another kind of change that you'll have to look into. Again, you're going to be using containers, so it's how do we get those containers into production versus kind of like hand copying files, which I've seen some places do. Obviously, don't do that, that's bad. The other one is clustering. So you'll want to look at how do we cluster multiple instances of the Docker engine together. And obviously, that's good for scalability and also reliability. You don't want just a single Docker machine running all of your containers if you can help it. So Docker have got their own called Docker Swarm. There is others available, such as Kubernetes or Mesos. So you have to just work out what's best for you. Most people these days are traditionally going towards Kubernetes now. And even Docker's kind of embracing Kubernetes support, I believe. So that's something to look into. Load balancing. Docker has got some built-in load balancing. So if I had multiple instances of my service running, it will actually load balance between the multiple nodes for me. But you might want to look at how do I load balance between two different Docker clusters potentially. As I mentioned previously, secrets management. So traditionally, the way that you pass stuff into Docker containers is through environment variables. And we saw that in the Docker compose file with the connection string, for example. But ideally, I don't want my password in clear text. Obviously, you'd lock down who'd got access to the Docker infrastructure, but you still want to maybe look at secrets management using, I think Vault is one of the products. But there's different ways to do that. There's some resources, and these are all hyperlinks that are available for you, that are in the slides, which are on GitHub. And I'll tweet out a link to those in a minute. Docker documentation is really, really good. They've got really strong documentation. So if you've got what does this command do, or how can I do this, their documentation is really good. You've got the Docker plugin for Visual Studio Code that I was using in the demo. And then on the right-hand side, you've got Docker plugins for TFS if you're a TFS shop or VSTS shop. But one thing you will need to look into is the last link on the right, which is the Windows Server Container licensing. It's last time I looked, it was a very complex licensing model, so good luck with that one. So thank you very much, everybody, and please leave feedback on the way out. Any questions? Yeah.
I had one about databases. Like, let's say I wanted to run the music store app, but I wanted to have the database just in a standard database instance, not running in a container.
Yeah.
It's hooked up with a compose or something like that. And I wanted to use a connection string that was using like trusted authentication. I read something like it required like root managed service accounts, but I don't know anything about it. Does that sound right? Or?
Yeah, so the GSMAs, I haven't used those personally, but yeah, you would need to do something like that. Okay. Last time I looked into them, the support was very bleeding edge, so we chose. So did we. So yeah, we did look into that, but unfortunately at the time it wasn't that usable for us.
Bleeding, not leading, right?
Yeah.
Thanks.
Any other questions? Yeah.
The performance issue we noticed, was it just on Windows?
Yeah, so it all comes down to the file system driver that Docker uses. On Windows, it's got a bad reputation for being extremely slow. So if you were to run the same build on a Linux-based host versus a Windows-based host, we've typically seen our build times on a Linux host be at least roughly 3 times less than on a Windows host. But .NET Core does give you the ability to run on Linux, so it's one of those things. It depends if you're a Windows shop or a Linux shop. Some companies are more on the Windows side, some aren't. Any more? Okay. Thank you very much, everybody.